So, good morning. The second segment. The other time I explained about restrained slab. Simply supported slab in two direction. Now, this time around, we'll be looking at the restrained slab in two direction. Now, the other time we use alpha SS when it is simply supported and in two direction. But for this particular one, we're using beta SS, and this is for the span along S direction, for the span along Y direction. You can see the formula, they look almost similar, so I will just make mention of the similarities between the two. For this, all other conditions remain constant, the way we calculate our ultimate load. Likewise, the area of AS over BD, percentage area of AS over BD. Now, in this particular scenario, we will not be using a single alpha SS or alpha SY the way we did the other time. Now we'll be calculating our beta based on the support or the restraint condition. Now, what I mean by restraint condition, we have the type of panel. Is it negative moment at continuous edge or at positive edge? Is it interior span, one short edge discontinuous, things like that, and depending on our Ly over Ls. Now this is for the long span, which you already know, but this is for the short span. Now for this particular to make this one clearer, let me show you an example of what I mean. Now let us look at this particular illustration here. These are restraint condition. Now this one is interior panel. Now when it is restrained at just one side here, you can see that this side is short and this side is long, so that means it's one short edge discontinuous. Now for this particular one, it is the long edge, one long edge discontinuous. However, looking at this, we have two adjacent edges discontinuous, and this one we have two long edges discontinuous, and this one we have just the short edge, the long edge, one long edge discontinuous. Now this one we have just the short edge discontinuous, and this one we have all the four edges discontinuous. Now that one will help us to have understanding of what we mean by interior panel, one short edge discontinuous, one long edge discontinuous. So depending on what we have as our Ly over Ls, that one will help us to know what we will take in this among all these values. When it is 1.0, we select this one based on the restraint condition. Now you can see this is an illustration of the span, the slab, and the edge. Now the way the distribution of reinforcement is, we have the edge strip, we have the middle strip, and the edge strip also. Now for the middle strip, which is just like Ly over L8, that is the 1/8 of the total span, 1/8 of the total span here. So here we have 3/4 of the total span. So the reinforcement is distributed in this manner. The total span length, the total reinforcement we have, the 1/8 will be distributed in this side, 1/8 will be distributed in this place, while the main 3/4 will be distributed in this particular span. Likewise, this for the span Ls, and this for the span Ly. So that means it will be running along this side for this particular one, and this one will be running along this side for this particular one. So the conditions of and now it consists of both top and bottom mats, each having bars in both directions of span, and if you extend from the edges, minimum distance is Ls over 5, and at the corner where the slab is discontinuous in both directions, have an area of steel in each of the 4 layers equal to 3/4 of the area required for the maximum mean span moment. Now all this stuff, they are what I have explained to you. So the same procedure we did in the other one is what we are going to do, but it's just this one is just an illustration so that you know what we mean by two adjacent edges discontinuous and things like that. So we have what we call a negative moment at close to the support. So that's why we use this one, the negative moment, and the other one for the other one. I think I have a little okay. The notice this. Okay, I don't have any explanation on that. But we have the negative moment is always closer to the support. So because it's restrained. So I think that one is illustrative enough. Let us look at this example. We have this, just like the one we treated. Let's say this is 5 meter, this is 6.525. This is the longer span, this is the shorter span. Now the what's it called, the Ly over Ls, which is this over this, which is 1.25. Since we have 1.25, now the next thing we do is we come to this table 1.25. Now what's the restraint condition? What's the restraint condition? Let's say for this particular one, you can see the way we have a support here, we have a support here, we have support here. So it's only discontinuous at this edge. So is this our long edge? Definitely this is our long edge. So discontinuous as the long edge. The one long edge discontinuous, and we have what 1.25. So what I'm going to do now is 1.25. So one long edge discontinuous. So that means we are taking this guy, one long edge discontinuous. We're taking this guy for our moment along the S, and this one for the moment along the Y, or for the longer side. So 0.059, 0.045. Let us go and look at it here. 0.59, 0.59 for the 0.59. This is for the S. Then we take this one for the Y, 0.037. Then for the span, we have 0.045 and 0.028. So for this one we have 0.045, 0.028, and this one we have this for the mid span, while for the negative moment 0.059 and 0.037. So the same thing, the same way we calculated the area of reinforcement, we calculate the area of reinforcement, and that is all on this particular restraint slab. So I will give each group a particular task based on what I have here. You calculate the calculation for me. So let us say according to the list in the class, we write a list. In the list, let's take group A, group B, group C to F. That's 6 groups. So in each group, let's say group A now. Group A, this is what they are going to do. They are going to take this particular N to be 15. N will be 15 for group A. Group B, N will be 20. Group C, 25. Group D, 30. Group E, 35. Group F, 40. So you know what your N is. So now the Ly and Ls. Now for the group A, you are going to take 6 meters here. Group B, 7. Group C, 8. Group D, 9. Group E, 10. And group F, 11 meters here. No. Let me take it again. Sorry. Let me come again. I think that's on the other side. Let me take it this way. Group A, take this as 5.5. Group B, this is 6. Group C, this is 6.5. Group D, this is 7. Group E, this is 7.5. And group F, this is 8 meters. Now for this, your Ly, group A, take it as 6.5. Group B, you take this as 6.75. Group C, 7. Group D, 7.25. Group E, 7.5. Group F, 7.75. So you already know what it is. So I want you to calculate the area of reinforcement that is needed, and you let me know, and I will be collecting that at the end of today. So you do it at my period now, and then you get back to me at after my Orion class. I will also send a video for the Orion. I wish you good luck. Thank you.